This demonstration shows Shark's ability to create 2D drawings from 3D parts. This is accomplished through the Model to Sheet tool palette located near the bottom of the tool palette. The tool palette consists of the ability to automatically generate 2D drawings from 3D parts, which is the first icon. Second icon is to manually create drawing views. This is like a view that sets the view orientation to side, top, front, isometric, trimetric. Auxiliary views, section views, detail views, and regenerating draw views. All the draw views are associative to the 3D parts, such that if changes are made in the 3D part, they will reflect back into the 2D drawing. Let's go ahead and create a drawing from the part on the screen. The dialog that comes back displays the options that we have for creating our drawing. On the top we'll see the type of layout that we can choose. These can include the draw views, which may have a layout of a side, top, front, isometric. It also includes a title block. If you want to have your own custom versions, just put them inside the template folder and they will appear in this dialog box. The method includes how the hidden lines are generated. For example, they can use precise curves, which is based off of some licensed technology from CATIA V5 from Dassault. Same drawing technology that they're using. Polylines, which is faceted lines that get generated. The advantage of that is they're very fast to generate. And flat, grow, and phong, which are rendered images of the data. Over on the right side we see pen styles. These are different options of pen weights, styles, and patterns associated with different visibility. So for instance, visible lines, hidden lines, holes, tangents, and outlines. Let's go ahead and generate a part using the options as they are. What's happening now is it's taking our part and it's precisely generating side, top, front isometric views that were laid out in the template. Let's go ahead and zoom up on one of these. Next, let's go ahead and generate a section view. We'll generate a section view. We'll highlight the view that we want to generate the section from. We'll pick a vertical section at this location and we'll tear it away for the location of the resultant view. Now the section view will place an associative dimension with the location of the section view. Note when you move this section view, the section over here will update. The resulting section view has within it the cross-hatched section of the solid, plus associated with the directions of the arrow, the solid that is split through the section plane behind it. Next, what we'll go ahead and do is generate a detail view off of the top view. We'll select the detail view command. We'll go ahead and locate the center of the detail view and then we'll place it. This is section view B with a scale factor of 2. Next, let's go ahead and let's throw in some dimensions on this view. I'm going to grab the sides of the drawing view. I'm going to pull it around a little bit to give it some room to add my dimension. Then I'll select the Smart Dimension and we'll select this endpoint, that endpoint, and then we'll put a location for it. Likewise, let's get a vertical measurement, pick a couple points, and locate the dimension. And finally, we just want to show you that the draw views are workable with other applications, and in this example we're going to go ahead and export this drawing out to Adobe Illustrator. We'll go ahead to the File, Export, pick Adobe Illustrator. We'll have our scale set from 1 to 1, and click OK. We'll label it our assembly AI file, and we're going to save it to the desktop. In addition to exporting out as an Adobe Illustrator file, we have the ability to export out as a DXF, DWG, which will read into AutoCAD LT, AutoCAD 2009, or anything else that supports reading in DWG files. Once this is finished, we're going to go ahead and double click on the file and read it into Adobe Illustrator to show the example output that you get from this format. Alright, I'm double clicking on the resultant file and bringing it inside of Adobe Illustrator. Let's bring it over here onto our screen, and let's quickly change our page setup. And we're going to zoom in on some of these areas so that you can see what came over. And in fact, let's go ahead and zoom around on the part. And let's go ahead and demonstrate that these are they've gone over into Adobe Illustrator as Bezier curves, so that you have handles that you can edit them with. Let's go ahead and grab it, and we're going to ungroup it, and we will select one of these curves, and let's just pull out the handle on it. Alright, let's go back over into Shark LT, and that gives you an idea of some of the tools available with the model to sheet tools with Shark.